Welcome. In this lecture, we're going to continue once again with kind of understanding this notion that when you have some values and a relationship between them, that all possibilities for these values can give you some kind of shape in a Euclidean space. And I want to shift we're still in R2, but I want to shift to looking at a circumstance where you're actually looking at the graph of a function. So this is example 3. In R2. So again, we have our x-axis and our y-axis. So my x-axis and my y-axis. Maybe just do this. So this is my y-axis. And then what I've got going on here is that y. Well, let me draw it first. I'm going to draw something like this, so it's going to look like this. And what's happening here is that I have that y is going to equal, let's just do it this, is going to equal x squared. So that's the equation for this, or a point on here. If I took a point like this point xy is actually going to equal, so this is going to equal, x, and then f of x. So this is going to be f of x. Right. 4, and this is where we have that f of x is going to equal x squared. Okay, so this is the graph of this particular function, and the points look like your input and then your output for that function, right? And so here, in kind of, analogously to what we've been doing, that what we'd have here is that the parabola, this is a parabola, so the parabola, so that parabola that we just drew, it's just the graph of that particular function, is all the points xy satisfying that y is going to equal, so y is actually going to equal this f of x, or in other words, we have that y is going to equal x squared. Okay, so what is a real-life example here? We could say, so this is our real-life example. We could have something like all possibilities for points TD. So this could be all possibilities for points TD okay, where the distance, so where the distance d traveled is the time t, and then it's going to be squared. So in this case, it's this relationship between the time and the distance that's traveled in that time. But in this particular circumstance, because of the function, this distance would actually be the time squared. And it would have to be that. Okay, so I hope that made some sense. And I will see you in the next lecture.